Hi, everybody. Let's look at some defensive programming. Let's stop the hacks and vulnerabilities before they happen. Many exploits and security breaches are caused by insecure code. We want to look at how we can prevent these sorts of things and how the choice of coding language can help that also. So we always want to look at bad coding practices and not do them. Okay, so we want to use input validation. We want to take care of SQL injection. We want to make sure that we don't have buffer overflows. There's all kinds of things in here. This is a really good series of videos that I've watched on defensive programming. So, input validation, handle areas, boundary, range checking. Well, memory management, is that needed? Do we have to manage memory in Java and Python? They manage the memory themselves. This really applies more to C++. We want to follow standardized practices. Code reviews means we look at everything carefully, collaborate, document, comment. You've heard me say that before, and you want to be doing ongoing education. You want to be wanting to learn for the rest of your life. So let's look at some of the classic programs that can give trouble. Some of the classic things that can happen. One of them is called an integer overflow. Just like your car rolling over in C++, if we put in one too many numbers in our integer variable, it'll overflow. So the maximum value for a C++ integer is a bunch of numbers. The minimum value is the negative side of it. So I assigned these two variables, which I could have just done int max. Int max is a compiler definition that defines the maximum integer. When you compile the program, it looks at that and says, oh, we can't have any integers over this. And then here's my integer where I'm going to create an overflow. So first I print out the max and the min. Then I add 1 to overflow. Well, let's see what happens. Let me bring up my program. There it is. So instead of having 4, 7 and a positive side, because there's nowhere else to go, it has to roll over and start again at the very beginning, and we get minus whatever that is. That's an integer overflow, meaning you have put too many integers for that memory space to store. So how could we prevent that? Well, I guess we'd have to do some bounds checking. To say, oh, if it's over this, we can't do that, or something like that. We'd have to do some sort of input validation, wouldn't we? And as a matter of fact, the next program does that. Look at here. We set our variable to int max, right? And if somebody inputs integer max, right, we didn't actually get input from the user, but say they put in the maximum integer, we would check for that. Or if they put in higher than the maximum integer, we'd check for that. And if it didn't work, well, we'd say, sorry, we perform the operation only if the integer overflow didn't occur. Otherwise, we avoid the overflow. Right? So we're doing bounds checking, might be a term, input validation. Bounds checking is probably more accurate because we're trying to make sure that whatever the user enters is not outside the range that can be stored in memory. This checks for that initial overflow. If it is this or bigger, we don't do the operation. If this is 1 less, we can do the operation and we end up with the maximum integer. So there's a way that you can test for that. That you can bounds check for that. Now let's take a look at another case. With C++, there is no safety checking, there's no management, but Java runs through a Java runtime environment that's supposed to manage the code and take care of that. Well, let's see if we have a buffer overflow with Java. Let's run this. So now we've pulled up the maximum value, which is the same maximum value that we have for C++. We're going to subtract 1 from it just to get to a starting point 1 below. And then we're going to increment 4 times to see what happens as we get too close. So let's see what happens. there. See, we started out one, oh, for some reason mine doesn't do this right. Okay, well, anyway, there's an F in there for some reason, but you can see it starts out with 4.6, 4.7, minus 4.8, 4.7, because now it's coming back up. So yes, Java can overflow and underflow with an integer. So how do you fix that? Well, let's look at how you fix it. Here's the mitigation. What would you do to make sure that doesn't happen? Well, we still get our maximum guy. We have what's called a big integer class, which in Java allows us to get really, really big numbers. All right, so we convert the max value So we take our max value string and we create a new big integer out of it. And it holds a larger value that can't overflow an int. Or you make sure that you have bounds checking. That's the other way. C++ does have bigger variable sizes, just like Java does and Python does. And if you think it's going to get close, a good way to prevent it is like this. Make sure you use a big enough variable that you're not going to run into issues. Or you make sure you do bounds checking. Well, the last thing to know is that Python is very managed and it's very safe. It doesn't demonstrate integer overflow. It allocates more memory. You have to simulate overflow behavior by enforcing the size limit. So is that really what you would do? You really can't overflow Python because of its protected status. But you can see from this that we have our max value, our overflow value. We're saying this is the maximum value for our integer plus 1. And it's just going to keep going, and it's going to be fine. When we get down to this, we are simulating an overflow. Well, that's kind of silly to simulate an overflow, but what it does is it shows that Python manages much of that. So let's take it. This gives us the maximum value for a signed 32-bit integer, which is the same type we've been working with all along. So let's go ahead and see, it just keeps going. That's our maximum value. We can keep going and going. Python automatically allocates more memory space. So it handles this on its own, which is very nice. And in order to simulate an overflow, which is a bit silly, because how would you ever end up with code like this? So that the overflow value is greater than the max value, then you take the overflow value to the minus plus this to end up with a simulated overflow. Well, that's a bit convoluted unless you accidentally did it, but it does show that you can simulate it. But if you're programming normally and programming well, you shouldn't have trouble in Python. C++ can have trouble if you don't create a big enough storage area. When we're storing things as objects, things will automatically expand. If we set a character buffer that's an array, for example, to 5, that's all we can store. If there's 7 things, it gets pushed into the next available memory, which might run into something else. So if we get input and then we print it out, well, it looks normal, but it's really causing a problem that we can't see. Let's see here. Let's run the, I already built it. Just a second here. Let's run it. BUFF. I tried to print out the error, but it really didn't show up. But it is overwriting memory next to it. And notice that it comes up with a little red thing here. It says exit status 1. Well, that means that it did overwrite memory outside of its allocated memory, which can cause trouble with other programs. If you overwrite memory onto other programs, well, then you have corruption. And if someone can input more information than your program can handle, they can cause that program to do unexpected things. So how do we mitigate that? Well, we could do, if it's greater than this, have them do it over again. You know, if buffer is greater than 5, say story, we can't have more than 5 characters, try one more time. That's one way to do it. Do bounds checking, input validation. Another way to do it is, here it is. We can set the width of what's input by using I/O manipulation. We can say we will only accept 20 characters. After that, you're out of luck. That's another way to make sure that we don't get more information than the program can handle. Well, these are some of the ways that you create unsafe code. These are just demonstrations. You don't really want to write code like this. This is just to show some of the limitations.